This is a question under the topic of applications of differentiation. To solve this question, you need to recall how to form the equation of a straight line given its gradient and a single point on the line. Okay, so just a quick recap of how to do that. Let's say you're given a line, okay, and you have the gradient, which is okay. Let's say the gradient of this line is 2, and you have a set of coordinates that lies on the line as well, and it's 3, 4. Okay, so there are two ways to find the equation of this line. One is just write the line is y equals to mx plus c, right? We are given the gradient, and the gradient is represented by m, so we can just sub 2 in there. Okay, now we have one unknown c, right? We have a pair of coordinates that lies on this line, which means that given the equation of the line, right, if we know that the value of x is 3, then the equation should tell us that the y coordinates is 4. Right? That's how the equation of a line works. If you're given one coordinate, you can sub it into the equation and then it will return the other coordinate. Okay, so if you do that, you can solve backwards for c, right? That's the only unknown left. So in this case, c will be -2. So the equation of the line will be y equals to 2x minus 2. The other method would be to use the y minus y1 equals to mx minus x1 formula, right? And then sub in all the values that you know. You know that the gradient is 2, you know the set of coordinates that lies on the line, right? So you sub in the y coordinate, which is 4, and the x coordinate, which is 3. And then you just make y the subject. Okay, it'll give you the same thing, y equals to 2x minus 2. Okay, so for this question, right, they want you to find the gradient of the equation of the tangent and the normal to the curve. Just to recap what a tangent is, tangent is a straight line at a specific point. So down here they tell you x equals to 2, right? Let's say x equals to 2 is here. Then the tangent will be the straight line that you can draw that will only touch the curve at one point. Okay? Normal to the curve, same thing. You need to specify which point you're talking about. So they say x equals to 2, right? The normal will be the line that's 90 degrees to the tangent. Okay? So you can see that both the normal and the tangents are straight lines, right? So to find the equation of the curve, right, you'll need these two pieces of information. You'll need a set of coordinates that lie on the line as well as the gradient. Okay? So let's try and find the tangent first. Okay? We get rid of this. Okay, so to find the tangent of the curve at the point where x equals to 2, to find the gradient, right? Remember, we can differentiate the curve. Because when you differentiate the curve, you will get the equation of the gradient, right? So dy dx, you'll get 2 minus x, the power of -2, which is 2 minus 1 over x squared. Okay, so to find the gradient of the curve at this point, we sub x equals to 2 into our dy dx. So you get 2 minus 1 over 2 squared, which is 2 minus 1 quarter, which is 1 and 3 quarters. Okay, 7 over 4. Right. So, yeah, at the point where x equals to 2, right, our gradient is 7 over 4. Okay, so let's say our curve looks like that. Right, our curve doesn't actually look like that, but let's say it does, right? The gradient at this point will be 7 over 4. And the gradient at this point will be the same gradient as the gradient of the tangent here. Right? You need to separate the concepts of what a tangent is and what a gradient is. The tangent is not the gradient. The tangent is a straight line that touches the curve at that point. And it will have the same gradient of the curve at that particular point. Okay, so now we got the, like for the tangent, okay, we got the gradient already. The gradient is 7 over 4. Right, now we need a set of coordinates that lie on this line. Okay, we know that at this point, right, x equals to 2, right? So how do we find the y coordinates? Okay, remember this is a point that lies on the curve, right? Okay, it lies on both the curve and the tangent. So if we have the equation of either of these two, right, then we can find y. We don't have the equation of the tangent, so we can use the equation of the curve, right? So remember to use the original equation. Okay, don't use the dy dx equation, because when you sub x equals to 2 in here, it doesn't give you y, it gives you the gradient at that point, right? So sub x equals to 2 into the original equation. So y equals to 2 times 2 plus half. So that's 4.5, right? So the y at this point will be 4.5. Okay, so yeah, now we have both pieces of information ready. We can find the equation of the tangent. All right, let me just tidy all this up. Okay, so yeah, remember how to find the equation of the line, right? Equation of the tangent will be okay, y equals to the gradient mx, right? The gradient is 7 over 4 x plus c, right? How do we find c? we sub the set of coordinates into this equation first, right? We know that when x is 2, our y should be 4.5. Okay, so we will have 4.5 equals to 7 over 2 plus c. We multiply 2 on both sides, right? Or okay, never mind. We just make c the subject. So c will be equal to 4.5 minus 3.5, which is 1. So the equation of our tangent is just y equals to 7 over 4x plus 1. Okay, so to find the normal of the curve, right? Same thing. Remember, the normal of the curve is the line that is perpendicular to the tangent. Okay, so we can reuse this set of coordinates, right? We don't have to solve for that again. Okay, for normal, right? We have to find the gradient. We don't know that yet. Okay, but the set of coordinates that we can use will be 2 and 4.5. The reason being because this